everybody. And I will just take a second to open my presentation slides. So thank you very much, Alexander, for introducing me. And well, I should say maybe a few words that last time I was at the kgh-kongres exactly 10 years ago. At that time, I was a student volunteer. I was working on the registration desk, helping other participants. So now, fast forward 10 years later, I'm actually very happy to be here, and it's a great honor to be invited. Thanks to Alexander, and thanks to the organizers. And another thing I should mention is that I'm happy that I can be part of this indoor environmental quality session, because kgh conference is largely focused on very system-centric design of buildings, and specifically HVAC systems, which is important in terms of efficiency of the systems and energetic performance, but also we should ask ourselves a question: for who do we design the systems? It's of course the answer is people. So basically the merger between efficiency of the systems and how those systems impact people, it's something we should not neglect. And I'm hoping that in the conferences to come we can keep talking about these topics. So today I'm going to talk about indoor air quality and satisfaction of people in green buildings, and I'm going to present some just preliminary results. So it's a pilot project which is ongoing. So bear with me, and before I get there, I just want to a little bit talk about my lab. Just 1 minute to say that the name of my lab in Switzerland is called the Human-Oriented Built Environment Lab. And we basically explore intersections between building systems and how they affect people, and specifically how the systems impact quality of air that we breathe in buildings, and also the thermal comfort in indoor environment. There are 4 research areas that we cover. One is pollutant dynamics in indoor air, where we basically try to quantitatively describe relationships between air pollutant sources in buildings, and also their concentrations and subsequently fate in indoor environment. Also, we try to understand what air we exactly breathe, human air pollutant exposure. We also deal with more practical topics, smart ventilation and the Internet of Things. We have a couple of early projects right now, and also the topic that I'm going to talk about today is more general air quality and comfort in buildings, where we basically try to understand on the large scale what is the impact of building retrofit, energy like retrofit, on indoor environmental quality, what is the impact of different ventilation systems, and what I'm going to talk about today is what is the impact of green certification of buildings on indoor environmental quality. So speaking of that last topic, I'd like to say that we all have witnessed the huge expansion of multiple green certification programs. What you can see on this slide is just a small snapshot of what is out there worldwide. We have around 1 million green certified projects. Here, perhaps to mention a few, LEED, most of you are familiar with. BREEAM, which is the very first green rating system that comes from the UK. Perhaps some of you have heard about WELL. Do you mind raising a hand if you have just heard about WELL certification program? Okay. Very few. So my talk is going to be more focused on that certification program, and like later on you're going to learn about it a little bit more. So what I want to say that when we talk about the green buildings, between these different certification programs, they all have basically one common objective, but also a little bit different features. But their common objective is to minimize environmental impact by reducing the site disturbance, by reducing the energy and water use, reducing waste generation, and also their goal is to promote human health and occupant experience. So currently we have around 200 building certification programs worldwide. So I've looked into the existing state of the literature in terms of how green building certification schemes impact indoor environmental quality in buildings. When I talk about indoor environmental quality in buildings as a whole, we refer to indoor air quality, thermal comfort, lighting, acoustics, ergonomics, and all these other building features which impact human performance, human experience, human health. So what we found by investigating the literature is that in most of the existing studies, and there are not too many of them, but those existing ones mostly say that green buildings, green certified buildings outperform conventional buildings with respect to indoor environmental quality. Because the evidence is limited, we certainly need more evidence to make these as a general conclusions. And particularly with respect to indoor air quality, relatively little research has been done to basically look into how different indoor air quality related features within green building standards affect indoor air quality. So that's very general about green buildings, but I want to bring your attention to one more recent direction. There is a recent shift in green buildings with the appearance of the new green rating programs, which specifically focus on so-called human health and experience in buildings. And they are also called healthy buildings, whatever that means. But interestingly enough, the most well-known new green rating system which really promotes human health in buildings is called WELL. Just a fraction of you have heard about it. And I think the third talk today it's going to be done by Dušan Ličina, with the last name quite familiar to me. So one might ask a question: why do we care about designing and operating as so-called healthy buildings? And you will have a chance to hear about that more separately. So what we did, basically, we took 3 case studies. We selected 3 companies in Europe which are located in 3 buildings. And we found a situation where they're either in a conventional regular building or other green certified building, and they are planning to relocate into WELL certified building. And that's exactly what we found. And the key point here is that we are using the same group of people. So the same group of people is relocating from non-WELL certified building into the WELL certified building, and in that way we wanted to basically quantify the effect of WELL certification, how it impacts not only the physical environment but also how it impacts the human satisfaction. So as you can see, this is an ongoing project. So as I said, I'm gonna just present some very preliminary results. For the first case study, the group of 450 people is relocating from a BREEAM certified building into WELL certified building. We have done 2 stages, and now we're just preparing for the very last stage of investigation. And then we have another 2 buildings, case study 2 and case study 3, which is basically an ongoing study. So today I will just chat a little bit about the very first case study, what we have learned so far. So the building, the company is located in Amsterdam, in the Netherlands. This is how the building looks like. So on the left-hand side we have a BREEAM certified building, and the BREEAM certification scheme is largely focused on energetic performance of a building. They do have something related to indoor environmental quality, but energy is really in focus, as opposed to WELL, which is promoting so-called health and productivity of people in buildings. So just a few details about the methods. So building is located in Amsterdam, as I said, 450 employees in a company, and we had like relocation happening in a springtime of 2019. So we did the assessment of the winter time before relocation in old building, after relocation in the summertime, and now we want to do another set of investigation in the same season in order to be able to compare the two very same seasons in the two different buildings with the same group of people. So we did the 1 month long physical measurements of indoor environment, specifically on indoor air quality. We investigated the different space types, open office space, meeting room, private office, and we did combination of passive and active measurements. When it comes to active measurements, we characterized the levels of carbon dioxide, temperature, relative humidity, and also size segregated airborne particles, classified in 6 size groups. And when it comes to passive sampling, we characterized individual volatile organic compounds, which are different chemicals in the air that we breathe from off-gassing from building materials and people, as well as aldehydes. In addition to physical measurements, we have also performed subjective surveys. We have surveyed basically all 450 people, and we collected approximately 50%, 45% of responses. We had more than 200 responses in both buildings, pre and post relocation, so it's in a way a significant sample size for that one particular building. And we ask a variety of different questions, from how they feel about different indoor environmental quality factors, how they, in generally are satisfied, how they assess their performance and productivity, and also we ask for some sick building syndrome symptoms. So we use this very standardized scale from -3 to +3, from very satisfied to very dissatisfied, and we apply some statistical tests to derive certain conclusions. So I'll just run through a couple of preliminary findings. So we have here 2 graphs. The graph on the left is showing the carbon dioxide performance of the 2 buildings, and PM10, which stands for particulate matter smaller than 10 microns in size. So, like we can see in general that the carbon dioxide level was in general acceptable. It was below the standard threshold limits. In both buildings, a little bit higher CO2 level in BREEAM building, which is largely attributed to a little bit more dense like occupancy, because they had a somewhat small surface area available. And also when it comes to particles, there was not a significant difference between 2 certification schemes. So generally acceptable levels when it comes to CO2 and coarse particles. When it comes to temperature and relative humidity, also we didn't find anything that interesting. So not much difference in the indoor temperature despite the different seasons. So we are here talking about summer and winter. However, when it comes to relative humidity, the well-certified building had a higher humidity level, and the reason is likely because it was a summertime measurements. So more interesting results do come from investigation of the volatile organic compounds. So as we can see, just while you're looking at the 2 graphs, pay attention to different scales that we have. On the left, we see BREEAM certified building VOC concentration. On the right side, well certified building concentration. So when it comes to concentration of the human-associated VOCs and BTACs, terpenes, there is not a larger difference. However, when it comes to a concentration of aldehydes and also special indoor VOCs, which come from certain building materials, we can see that concentration of those compounds in well-certified building was actually much higher than the BREEAM certified building, which is quite interesting because the WELL certification scheme that you're later going to learn about really puts a lot of emphasis on individual volatile organic compounds in terms of their reduction. So out of those special indoor VOCs, we actually found that ethanol to acetate and acetate had the highest concentration, and when we looked further, that actually came from one type of paint because well, certified building was relatively recently refurbished, and so the emissions from the volatile organic compounds from paints was still high. We also looked into other pollutants, so the TVOC, which is the sum of all volatile organic compounds in the air. It was significantly higher in the well-certified building, which was also the case for formaldehyde. Just what is interesting is that TVOC concentration in a well-certified building have at the same time exceeded maximum thresholds in a certain standard. In this case, like a German standard prescribes the upper TVOC limit of 300 micrograms per cubic meter, and VOC, well-certified building has exceeded that limit, which were quite surprising result. So when we switch to subjective results of occupancy surveys, we find something different. We find that occupants in well-certified spaces were generally more happy with the thermal comfort, with indoor air quality. Even though when it comes to indoor air quality, the physical environment was basically worse, but nonetheless, people were still more satisfied, which is interesting for several reasons. We also did comparison across other indoor environmental quality factors, and we found that occupants in well-certified buildings were more satisfied across different features, including the sound, privacy, visual comfort, noise level, and also workplace. So that was another interesting finding. And what we also did, so a caveat here, because we have a very small sample size, we also took existing databases, basically because these kind of surveys have been run in different conventional and green buildings, so there is some sort of a database out there which we collected, and then we did a cross comparison of our results from the well-certified building against a huge number of data samples from other databases, and despite having like a quite small sample size in terms of only one building, we tried to do this preliminary benchmarking, and we realized that results that we obtained in well-certified building, in fact, were much better across almost all indoor environmental quality factors that were surveyed in other buildings. So just to wrap up on this part, this is pretty much the first ever study to examine the well-certified building. It's a relatively new certification program, and we need to understand basically whether it is effective and whether we can change something in terms of the standard itself, that we can make it better in practice. We found no significant difference in terms of carbon dioxide temperature and particle levels, but higher volatile organic compounds were detected in a well-certified building as compared to BREEAM building. Despite that, occupants seem to be more satisfied in a well-certified building. However, the results for now should be taken, of course, with care, because we are having another 2 buildings, and now we're going to do like a new seasonal measurements where we'll be able to match 2 seasons. So we look forward to see those results. And also we are planning to expand the study further beyond this to include more buildings. So because Alexander was actually very kind enough to give me a little bit more time with respect to other speakers, I think now I use 15 minutes, but I will use another 5 minutes to try to put these results also in the perspective. Just to maybe give a more general picture of the building stock and where green buildings are positioning themselves in a building stock, and also why we're in a way detecting these kind of issues with high volatile organic compounds in such buildings. So if we look at this graph shows a very, very general overview of building practices out there, starting from so-called low breakers, or let's say sick buildings, which typically do not comply with even basic building codes, and which are characterized by different negative health symptoms exerted on people. And then we have approximately 70% of typical building practices, which are buildings that we most of the time occupy, which are designed to meet the standard requirements. However, in practice, we also encounter issues with that, because a building that is designed to meet the certain standard does not necessarily perform according to those standard requirements. So that's more an issue of design versus operation stage. Then we have so-called green buildings, which we have approximately 20% of the building stock in developed countries, which which sometimes are designed to meet or to exceed the regular standards, but also they have a set of issues. And then we have 5% innovators, which is probably where we want to end up in terms of the health and experience of people. So the issue here is that 20% of the buildings, green buildings, they often call themselves healthy buildings, which tackle like human needs, but in practice, basically there is no evidence to support this finding. So I just want to elaborate on that a little bit more. We can transmit these 4 building categories into this pyramid, which show how these 4 building categories have impact on people. It's so-called health performance pyramid. This is basically just my view, so some people might disagree with this. So the green buildings, I position themselves in the level 3, which are basically striving to enhance the positive benefits on people. However, they often claim to belong to this level 4 category, which I do not necessarily agree with, which is basically integrated management of health and human experience along with the energetic performance of the building. So why green buildings claim to be here, and they're likely, they still have a way to go to get there. I classify that in a couple of challenges, which I just want to briefly share with you. That currently there is a significant gap in terms of, like, when you read different green building schemes, there is still a significant gap between the relative emphasis of energy-related features and those that promote human health. So there is a huge emphasis on energy savings, and when you look into different studies, you actually find that across all the green building programs, only around 7 to 8% is attributed to indoor environmental quality. So there is much more priority given to water resources, to energy resources, to green economy, and so on. So that's like one of the challenges we're facing. Challenge number 2. Basically, most of these standards they lack established protocol for performance testing. So, like, very often, like, those buildings are not verified in terms of how they perform once they're built. And why we chose the WELL standard is because it's the most rigorous what we have currently on the market. So it's basically the best, let's say, the best practice out there. But we still detected a lot of shortcomings. When you look deeper into the standard itself, you're going to hear later more about it. performance testing of the building is done once every 3 years with very sporadic measurements. You know, the well assessor comes to a building once every 3 years and does certain limited measurements like 1 hour in this room, 1 hour in that room, and that's what we, based on that, we judge the performance of the entire building. Also, there is now some early experimentation with the IoT sensing, continuous monitoring, which is still facing certain challenges, not only in terms of like hardware development, but also in terms of the guidelines how these IoT sensors should be used. Challenge number 3, and I'm also approaching the end soon. There is, in general, no established health-based indoor guidelines. Most of the time, we simply refer to outdoor air quality guidelines, and we copy-paste them for indoors. So basically, our environmental health knowledge is rather incomplete. So that's why, as a result, we have something that green buildings claim that they're healthy buildings, but basically there are no any performance data to support such claims. That's why we end up with these kind of problems. And last but not least, when we look into the literature, what has been done so far on the green buildings, we can see that the biggest pool of knowledge belongs to energy-related research, with which is followed by just a survey-based investigation of green building. Already when we come to like physical measurements, which is something what I presented, combination of occupancy survey and physical measurements in green buildings, there are basically just a few studies which exist so far. And direct evidence for health basically does not exist. So like nobody has ever proven that you know, green buildings are in fact healthier. Like direct evidence is still not there, even though we call them healthy buildings. So these are some things like we should definitely be thinking about as we move forward. So yes, I use this additional 5 minutes just to put the results a little bit in perspective. And with that, I would like to thank you for your attention, and I will leave you with this Mayan pyramid, which basically presents what I just spoke about, how buildings can impact people on different levels. And well, credit for this photo to my wife, Veronica, who positioned me into unacceptable and sometimes sufficient level of the buildings. So thanks for your attention.